Set data structure. Okay, for our lesson today, I want you to take a quick journey back to your school days. Do you remember in your math class when we learned about a topic called set theory? You would see things written like this. A equal to set of numbers, B equal to set of numbers. You would then perform operations like union and intersection, and we would often draw circle diagrams called Venn diagrams to visualize what was happening. Well, the topic we are covering today in Python's data structure is the exact same concept. Today we are going to learn about one of the Python's most powerful data types called a set. You will see how we can perform those same operations we learned in school, union, intersection, and more. But this time, we will perform them using Python functions. And we will discuss the important role that sets play in the world of programming. Okay, let's create a new file and name it mysets.py. How to create a set? You can create a set directly using curly braces, just like in math. For example, my underscore set equal to open and close curly braces, 1, 2, 3, comma, 4, comma, 4, comma, 5, 5, 5. Note the duplicate items in this set. Let's print it to see what Python does. Print the set with duplicates removed, comma, my set. Important property. Sets only store unique items. Duplicates are automatically removed. Let's check. Let's check its type. Print type is, comma, type, my set. Let's check. Important property. Sets are unordered. This means you cannot ask for an item by its position, index. This line would be cause a type error. My underscore set between open and close square brackets, like this. How to create an empty set? You cannot use double curly braces like this. Empty underscore dict equal to. This creates an empty dictionary. Be careful. Let's check the type. The type of is type empty dict. To create an empty set, you must use the set function, like this. Empty underscore set equal to set function. Print the type of set is type empty underscore set. Let's check. Basic operations, adding and removing. Let's create a set of guest names for our VIP party. Guest underscore list equal to Sarah, Hama, John. Print original guest list. Let's check. To add a single new item, we use the add method. Guest underscore list dot add Alex. Print after adding Alex, guest underscore list. Let's check. What happens if you try to add an item that already exists? For example, Sarah. The answer, nothing happens. The set remains unchanged because it only holds unique items. Let's try to do. Guest underscore list dot add Sarah. Print after trying to add Sarah again, guest underscore list. Let's check. To remove an item, we can use remove function. Be careful. If the item does not exist, remove function will cause a key error. Guest underscore list dot remove John. Print after removing John, comma, guest underscore list. Okay, a safer way to remove an item is to use discard function. Discard function will not cause an error if the item doesn't exist. For example, guest underscore list dot discard David. David is not in the set, but no error occurs. Print after trying to discard David, who wasn't there, comma, guest underscore list. Let's check. Now for the most powerful part of sets, the mathematical operations, just like we learned in school. Let's create two sets of friends. Alex underscore friends equal to Sarah, John, David, Mike. Sarah underscore friends equal to Hama, John, Anna, Mike. Print Alex's friends, comma, Alex friends. Print Sarah's friends, Sarah friends. Let's check. Union operation. Who are all the friends in the group? A, U, B. The union combines both sets and removes duplicates. In Python, the pipe symbol or vertical bar is used for union operation, which is the same as the U symbol in mathematics. All underscore friends equal to Alex underscore friends, pipe operator Sarah underscore friends. Print union all friends, all underscore friends. Let's check. Intersection. Who are the mutual friends? Like this in mathematics. A intersection B. The intersection friends, the items that exist in both sets. Mutual underscore friends equal to Alex friends and operator underscore friends. Print intersection mutual friends, mutual friends. Let's check. Difference. Who are Alex's friends that are not Sarah's friends? Like this in mathematics. The difference finds items that are in the first set but not in the second. For example, Alex only friends equal to Alex friends, Sarah friends. Print difference friends only Alex has, Alex only friends. The order matters here. Sarah only underscore friends equal to Sarah friends, Alex friends. Print difference friends only Sarah has, Sarah only friends. Symmetric difference. Who are the friends that are not mutual? The symmetric difference finds all items that are in one set or the other, but not both. We can use this operator in Python. Non-mutual friends equal to Alex friends. Symmetric difference operator, Sarah friends. Print symmetric difference, non-mutual friends, comma, non-mutual friends. Let's check. So, as you can see, a set is an incredibly powerful tool. It's perfect for when you need to store a collection of unique items and perform mathematical comparisons and operations on them very, very quickly.